Hi everybody, in this video we will be going over negative exponents. Our essential question for today is, how is the rule of negative exponents used to simplify exponential expressions? So one more time, how is the rule of negative exponents used to simplify exponential expressions? So from this point we have talked mostly about positive exponents, but today we'll talk about negative, and we've also covered the power, product, and quotient rules. And so today we're going to talk about negative exponents and how all of those rules are used with negative exponents. But first let's talk about the difference between positive and negative exponents. Now think back about positive exponents. This states how many times a number must be multiplied by itself. Okay, so for instance, if I had 5 to the third, that's telling me that 5 is being multiplied by itself 3 times. So 5 times 5 times 5. 5 times 5 times 5, yes. So from here, we can also look at another example where we've got 3 to the fourth, and that tells us that the 3 is being multiplied by itself 4 times. So 3 times 3 times 3 times 3. So positive exponents are talking about multiplication. Now, when we think about negative exponents, negative is the inverse of positive exponents. So instead of talking about how many times you're multiplying by that number, you're talking about how many times you are dividing by that number. So if we had 5 to the negative third, what we have to first do is we have to make that a fraction, because that's the only way we can get that negative exponent to become positive. And think about that. Before, when we look at something like this, it makes you think, oh, I need to do, 5 times itself a certain number of times. However, with negative exponents being the inverse, it's telling us we need to divide. So to do that, we have to move the negative exponent to the denominator. So the general rule is that anytime you have a negative exponent, whether it's in the numerator or the denominator, you're going to move it to the opposite place so that it can become positive. So in this sense, think about this. This was 5 to the negative third, which really is over 1. So to find the inverse of positive exponents, you have to flip it to make this now positive, which then tells us that that is just 1 over 5 times 5 times 5, which is 1 over 125, so it's a much smaller number. So your goal with negative exponents always is to get those negative exponents to be positive by moving it to the opposite place that it is. All right, so let's talk a little bit more about negative exponents and steps for simplifying them. So to simplify exponents with positive or negative numbers, we need to follow these 2 steps. So first, try to combine all exponents with like bases. Now, you might have to use the product rule for this. You might also have to use the power rule. And the most recent one we talked about was the quotient rule. So try to combine as much as you can first, that's like a W, by using the product, power, or quotient rule before you even try to get those negative numbers to be positive, because you might save yourself a lot of work that way. And then your last step is to turn all those negative exponents into positive numbers by moving them to the other side of the fraction line. And then if you need to do some more combining, then you also need to do that. And really, it doesn't matter what order you complete these steps, it all works the same either way. By trying to combine everything with like bases first, though, you might save yourself some time. So let's look at some basic, easy examples. So in this case, we've got 5 and then x to the negative 2. Now here's the error that I see a lot of people make. They go, oh, I remember that first example, and I know I moved everything to the bottom, right? And then it becomes positive. However, that is very, very, very wrong, because x is to the negative second, but think about 5. 5 doesn't have an exponent here, so it means it is to the first. So ask yourself, which ones are negative? And when you find those numbers, those are the ones that need to be moved. Now, the only one that is negative is the x. So I'm just going to circle that. And that tells me that it needs to move to the other side of the fraction line. And our fraction right now is really this number over 1. So all we do to make that x to the negative second positive is we just move it to the denominator, and that's it. There is nothing else that you have to do on this problem, because there's nothing else to combine and everything is positive. Let's look at another example. Now this one kind of brings in that first step a little bit that we didn't have on the last problem. It says combine all exponents with like bases. Now we have the like base is 3, and we see that we are using the product rule. And the product rule tells us that we have to add. So all you're going to do is add all these exponents together and then worry about your negatives, because you could move all these to the denominator, but you're going to create a lot more work for yourself if you do step number 2 first. It's not that it's wrong. You'll just create a little bit extra work for yourself. So based upon the product rule, we simply add all those exponents together. So negative 2 plus a negative 4 plus a positive 3 gives us 3 to the negative third. Now, remember, this is basically 3 to the negative third over 1. And to be able to get this to become the inverse, okay, and to make this positive, we have to move it to the denominator. And when we do that, once this is gone, remember, there is a number in its place, and that number is 1. So you end up with 1 in the numerator, and now that 3 to the negative third has moved to the denominator, so that it has become positive, because that's the inverse. And then 3 to the third is simply 27. Okay, let's look at another example. Okay, so first thing, let's write in any exponents that we don't see. So 2 is to the first, and it's important to write that in, because a lot of people will think, oh, that 2 is to the negative 3, but it's not, okay? Unless it was parentheses. If you saw something like 2x to the negative 3, and you had the power rule, then yes, that 2 will be to the negative third. But in this case, no, it is not. And then the 5 is also to the first power. So let's underline our negative exponents, because that tells us it's going to move to the opposite place. So we've got x to the negative third and the y to the negative second. And so this x to the negative third is going to move to the denominator, so it becomes positive. And then the y to the negative second is going to move to the numerator, so it becomes positive. Now ask yourself, does the 2 and the 5, do they need to move? Well, first ask yourself, are these negative exponents? No. So if you say no to that, then you know they do not need to move, because only the negative exponents need to move. And then your answer is very simple. You just moved that y to the negative second to the top, now it's positive, and that x to the negative third to the bottom, so now it's positive. So remember, negative exponents are all about being the inverse operation. And to make it positive, you have to do the inverse operation, just like we do in equations. This time, we have the power rule. Okay, so we see the power rule, and we do see a negative exponent. Now, could you change this to positive right now? You could, but I do think you would create a little extra work for yourself. So evaluate and combine all exponents with the like bases first, or use those rules to try to simplify as much as possible. So when we distribute this, first write in any exponents you don't see. So this is 4 to the first. That is important that you do that very, very first thing, so that you know that this 4 does need an exponent. So the 2 distributes to the 4 to the first and to the x to the negative second. So when we multiply, that becomes 4 to the second and x to the negative fourth, because a negative times a positive is a negative. Okay, now underline any negative exponents or circle them so you know what needs to move. And we see that this is over 1 right now, but right here we have got our negative exponent, okay, which means it's going to have to move to the denominator to become positive. So all we have in the end then is 4 to the second is positive, so it stayed up here and became a 16, but since this was a negative exponent, it moved to the denominator to become positive, and that's all you have to do. All right, let's look at a few advanced problems where we combine several of the rules together when we're using negative exponents. Okay, now first things first, if you see any numbers that don't have an exponent, add that exponent in. And right now, that 2 is to the first power. It's important to remember that. Now I see the power rule, and I see the product rule. So I've got a couple rules, and then I also see some negative exponents here. So I've got quite a few things that I need to do first. But remember, try to leave the negative exponents until the very end. Simplify as much as possible and then work on the negative exponents. So the power rule says you multiply. So this becomes, well, and think about this, negative 3 times a negative 2 is a positive 6. So that's kind of nice. We actually got rid of a negative exponent by multiplying, whereas some people would try to make them into the fractions, and it gives you a lot more work and it's not very pretty. Now we've got the product rule, and the product rule says that you add the exponents together. So the 2 doesn't have any other bases to be added to, and there's no other coefficients for it to be multiplied to. But we've got an x to the 6th and an x to the negative 8th. And since the product rule tells us to add, we say, okay, negative 8 plus a positive 6 is going to be a negative 2. Now again, keep that 2. Remember that that is to the first power and it's positive. So since it is positive, it does not have to move. And really, you're saying right now that you've got 2x to the negative 2nd over 1. So to make this x to the negative 2nd a positive, it needs to move to the denominator. And then I'm left with 2 over x to the 2nd, because the 2 is to a positive 1, which means it does not need to move. But the x is to the negative 2, so it moves to the denominator. All right, oops, and I went from 5 to 6, so maybe we only have 2 more examples left, or one more example. So example number, I guess this would be 6, not 7. Let's look at this one. So this one, let's look at what rules we see. I see I've got the product rule on the bottom. And since I see a fraction bar, I've got the quotient rule. And I see some negative exponents. So let's try to simplify as much as we can first. Now on the bottom, I see the product rule. And I need to add in the exponents for the ones that I don't see. So that becomes 4 to the first. That's 2 to the first, that's 4 to the first, and x to the first. Now, 4 times 2, that can be combined, and that becomes 8. And that x to the 2nd and x to the first will give us x to the 3rd. So as you can see, we just combined our coefficients, okay? And x to the 2nd and x to the first became x to the 3rd. Now, think back to what we did during the quotient rule. And what we want to do is try to get at all those variables on and those exponents that are attached to it kind of on the same level. Before we do that, though, we can simplify 4 over 8. And think about that. What's 4 over 8? That reduces to 1/2. But, oops, and it looks like I went in a different order here. Sorry. So what I did right here in this step was, if I see that I've got negative exponents, so here is a negative exponent here, and here is a negative exponent there. They both need to move to the opposite place to become positive. So when y to the negative first moves up top, it becomes y to the first. And when y to the negative first, that's in the numerator, moves to the denominator, it also becomes positive. Okay? Now, since they're both positives, what you see happening here is, well, I mean, think about that. Y to the first over y to the first. That's like y over y, which becomes just 1. Or really, it's kind of like with cross-canceling, it just cancels out. And so those are just gone now. And so we're left with 4 over 8x to the 3rd. And like we mentioned up here, we can reduce that 4 over 8 to become 1 over 2. And then we've still got that x to the 3rd. All right, so you've got a few practice problems to solve. Some of them are very similar to ones you tried on your notes, so give those a shot. And if you have any questions, please let me know.